Okay, let's get started. So let me share. Okay, so let me who's here? Okay, so hopefully you all did well on your midterm. So let me go to new. Okay, so today we will go over derivatives. So nothing that too bad. Um, just basic properties of differentiation. So we say f is differentiable at a if and only if limit x goes to a, f of x minus f of a over x minus a, exists, right? So we normally call the call limit f prime at a. So in words, it's derivative of f at a. So, right, exists and is finite, right? Exists and finite. So there's a theorem that basically says, okay, if f is differentiable at a, then f is continuous at a. So note here, it's very easy to see this, right? What does continuity mean? So recall that continuity means this, right? In particular, you can sort of see it's basically this is small, right? Basically f of x minus f of a goes to 0 as x goes to a. And you see that it's clear from the top that this is just sort of like the numerator, right? So note that if from the top, you see that if x goes to a, what does the denominator go to? So denominator, if you plug in a, you get a minus a. That's 0, right? So if you think about it, if the bottom is 0, the only chance for that limit on the top to exist is if the top goes to 0 too, right? Because if you think of like, if it doesn't go to 0, let's say that our common example, like this, right? This doesn't exist, right? But the point is like, if you go from like the right, this is positive infinity, right? And if you go from the left, it's negative infinity, right? Because the bottom's 0, but the top is not 0. So, and you can see it sort of blows up, right? Because if the bottom's 0, and 0 just means a really small number, right? So if you divide by a really small number, you get a really big number. So you see for the top to exist, then the numerator on the top has to go to 0. But the numerator going to 0 is pretty much continuity, right? Continuity is exactly like the numerator going to 0. So, okay. Any questions so far? So hopefully this theorem's clear. So if you could take a derivative of a function, your function is continuous, right? So famous example, f of x equals absolute value of x is not differentiable at 0 but continuous everywhere, right? So the opposite is not true. So you have continuous functions that are not differentiable. And it's clear, right? From here, if you just graph absolute value of x, it looks like a V, right? And at 0, there's a problem. If you think of absolute value as, derivative as slope, the reason it's not differentiable at 0 is because you have slope -1, right, from the left, and 1 from the right here. The limit doesn't exist, basically. Okay. Any questions so far? Okay, and obviously we have the differentiation rules. So we have, for example, CF prime at A is C times F prime at A. So when you take derivatives, we don't really care for C and R. We don't really care about constants. You could just factor it out. And we have, so product rule is sort of, it's not F prime G prime, right? It's given by this. And hopefully this is somewhat clear. Hopefully it's clear that it's not F prime G prime, because you see the thing, it doesn't split, right? So if you look at limit x goes to A, this is F prime at A, right? And if you're multiplying this thing, right? It's no, it might no, not necessarily equal. So this means not necessarily equal to this, right? Like it doesn't really factor like you normally think it does, right? So sorry, at A, right? Because if you think of FOIL law, when you sort of multiply two things, right? Here, if you sort of multiply it, you get 4 terms, right? But here you get like 2. So you sort of see it's not really the right thing to do. So I'm saying it's not equal to F prime A times G prime A, right? So next, F over G prime at A. So again, you don't just do F prime A over G prime A. So it turns out that it's this, right? Hopefully we all know this, where G of A is not 0. Okay. And finally, we have chain rule. So we have G composed F prime at A is G prime of F of A times F prime at A. Right, so this should cover everything in the section. So any questions so far? Let me just see who's here. Huh, interesting. Okay. So then let's start going to exercise. So nothing too hard, right? You all learned derivatives. But so let's do some questions on, 28.1. So here, let's do part A, e to the absolute value. So we need to give the set where it's not differentiable. So, right, so here, e to the absolute value of x. So certainly, you all know that this is the composition of f composed g of x, where f of x is e to the x, and g of x is absolute value of x, right? So one thing you know is if, let me put it this way. If f composed g of x was differentiable at a, then what does chain rule give? Chain rule gives that it's, oh, I don't like this. So I put f compose g and g compose f. So let me, swap it just to be consistent. F prime g of a times g prime of a. Yeah, okay. So this is again just f prime g of a times g prime of a. Now, we know that e to the x is just e to the x, right? So here, this is e to the absolute value of a. Well, because g of a, so remember, f prime, what's g of a? If you plug in a here, you get absolute value of a times g prime at a, right? So this thing is just e to the absolute value of a. So there's no issue here, right? The issue comes with here. This is just derivative of g prime evaluated at x equals a, right? But g was absolute value of x, and we know that it's only not differentiable at 0. So we get that this whole thing is not differentiable, only at 0. Right, because outside of 0, absolute value of x just becomes x if x is positive, or negative x if x is negative. And we know that that's just a line, right? Y equals mx plus b, where m is 1 or negative 1 and b 0. And we know the slope of a line is constant. So here that's pretty simple. So let me do c, I think. Let's do one more. So sine of x. So again, this is a composition of two functions, right? It's the composition of f of x is absolute value of x, and g of x is sine x, right? Again, this thing is f compose g of x, where f of x is that and g of x is that. So here again, if f compose g of x was differentiable at a, then chain rule gives this, right? So times, right? So hopefully you all know derivative of sine, it's cosine. So this is cosine at a. So no problems here, right? No problems. But this is what? This is derivative of absolute value of x at sine of a, right? Because g of a is sine of a. So if you recall, absolute value of x is not differentiable at 0. So the question becomes sine of what is 0? So I trust you all know this, but it's gonna be multiples of pi, right? But you don't want like pi over 2. You want pi, 2 pi, 3 pi, 4. So it's not differentiable at a equals pi plus 2. I'll write pi k, right? For k and z. Okay, any questions so far? So this is C. Okay, let's get to some harder stuff. So let's do, 28.2. So let's practice definitions, right? So we all know, here we all know intuitively, for a, it's derivative of x cubed is 3x squared, and then you plug in 2, you get 12, right? But you can't really do that. You use definition. So was this 28.2a. Okay. So again, this is limit x. So let's go back. Our definition is limit x goes to a f of x minus f of a over x minus a. So in this case, a is 2. So here we go, x goes to 2, f of x minus f of 2 over x minus 2. And then you just plug in, right? So here it's x cubed minus 2 cubed is 8, right? And hopefully we all know that this factors, right? X minus 2, I think it's this, over x minus 2. And then you get the limit, right? Because this is just, there's no denominator anymore, just plug in. So you get 2 squared plus 2 times 2 plus 4. And you should get 12, right? So if you really want to reality check, you know the derivative of x cubed, right? So you can always just check by hand. Okay. Any questions? Okay. So they want x plus 2 at a. So a is arbitrary in this case. So, okay. Let's do that. So x plus 2. So, do they call it f? Oh, they call it g. Okay. At a. So again, so limit x. So we should expect the slope to be what? This is the line x plus 2. The slope, y equals mx plus b. The slope is m. So the slope should be 1, right? So here, x goes to a, f of x, or g of x, minus g of a over x minus a. So we should expect that a shouldn't matter in this case. So there's x plus 2 minus what? A plus 2 over x minus a. And sure enough, you get 1, right? Because you get x minus a over x minus a. Right, so the limit, so our slope is 1 for any a. And the next one, I think, is x squared cosine of, f of x. X squared cosine of x at x equals 0. All right, a equals 0, just to not, confuse x and a. So let's do limit x goes to 0. So again, it's f of x minus f of 0 over x minus 0, right? So here, f of x is x squared cosine of x. And I'm dividing by x, right? Because f of 0 is just 0. Because 0 squared times cosine of 0 is 1. So 0 squared times 1, which is 0. And you get the bottom cancels, right? So this goes to 0 times cosine of 0. So that's 0 times 1. This is just 0, right? So your slope is just 0 at 0. Okay. And is everyone comfortable with definition? Actually, like most of this is just definition, but the others get a bit harder. Any questions so far? Let me just, no one knew. Okay, so let's continue. So 28.3 is an important example. So let me just do part A. Point 3, so root x, which is x to the 1/2. So they want us to compute, right? So obviously you should expect, you all know power rule. You should expect this to be 1/2 x to the negative 1/2, right? So we should expect, right? They want the derivative at, some value bigger than 0. So so that you should want to show, they use h of x, I use f of x for all a, and so r bigger than 0, f prime at a is 1/2 a to the negative 1/2, right? So let's check this. So I get f of x minus f of a over x minus a. So here I get root x minus root a over x minus a. So again, trick is when you see square root, multiply by the conjugate. And sure enough, the top gives you sort of like the bottom, right? Just because you get x minus a on top, and then x minus a root x plus root a, right? So you just get that. 1 over. So if you just plug in x equals a, you get 1 over 2 root a, right? Which is another way of writing this. So yeah, we are done. But the important thing is, the derivative is this, right? Since it's for any a. And what you're gonna notice is this is just this. But this thing is, you could check, it's not continuous at 0, right? So this thing, it cannot be, cannot be differentiable. So why? Because if you go back to the theorem on top that I just wrote, a function that's differentiable is continuous, right? In other words, if your function is not continuous, you can't be differentiable. So the function here is not continuous, right? So basically I'm saying, they didn't really define this, but f double prime does not exist at 0, right? So an important thing to know is, to be differentiable, you need to be continuous. But the resulting function, f prime, after you take derivative, that resulting function need not be continuous, right? Like in order to take derivative of root x from r, r bigger than 0, I have to be continuous, and root x certainly is, right? And it certainly, but like the derivative can, introduce bad stuff. So you can sort of see the same thing for I'll let you do the next part, but x to the 1/3, right? X to the 1/3 is defined on all of r, right? It's continuous on all, and it's differentiable. But the resulting function is not differentiable at 0. You get like a denominator, right? So yeah, I guess I answered part C. So okay, any questions so far? Okay, let me go to 28.6. So this is another cool thing. So I'm just gonna assume it's continuous at x equals 0. You could show this, right? So we have that f of x sine of 1 over x for x not 0, and it's 0 for x equals 0. So we're basically saying, okay, the question asks, is f differentiable at 0? So I mean, I just want to say, like, if you see a piecewise function, you don't really need to be scared. You just go by definition, right? So limit x goes to 0, f of x minus f of 0 over x minus 0, right? It's the same process. It doesn't, just because the function looks a bit more weird, doesn't change anything. So what's f of 0? So f of 0, at 0, I'm 0, right? So I just have, f of x on top and x on bottom, right? Now, what is this? Now, x going to 0, I'm not 0, right? I mean, limit, we don't care about the actual point, right? We care about the terms going to it. So when x goes to 0, I'm not 0, so I'm x. So by the rule above, I'm x sine of 1 over x. And the x's cancel, right? So here, what do we get? So what is this limit? Hopefully you all remember. Does this limit, exist? Doesn't exist? What do you all think? Anyone? So you've done this question before, I think. Yeah, it has nothing to do with derivatives. It's just limits. So yeah, does not exist, right? Because the point is, remember, I don't know if you've seen the picture, but it looks like really wide, right? And then it goes like, sorry, it should be the same height, but it gets thinner and thinner, right? There's infinitely many going to 0. So basically, you could pick a subsequence that's all negative ones and a subsequence that's all ones, right? So if you choose like 1 over 2 pi k, right? So 1 over x is 2 pi k. Oh, in this case, it's all 0, right? So all 0. Limit is 0, right? Because sine of any multiple of pi is 0. But you could also choose like x to be like pi over 2 plus pi k. I'll do 2 pi k actually. Right? So let me think. Actually, let me think. It's actually not. I want. Okay, so let me do this. So I want 1 over x to be pi over 2 plus 2 pi k, basically. You can solve for what x is. But basically here, the limit is 1, right? Because, it's a sequence of, pi over 2. The reason I add 2 pi k is because I don't want 3 pi over 2. 3 pi over 2 is negative 1. But yeah, so here I'm choosing a sequence here and a sequence here. But I mean, there's many sequences you can choose. But the point is that a limit has to be unique, right? So if you choose 2 sequences and the limit, that converges to something different, you're done. The limit doesn't exist. So okay. So this is another example, right? You have in your, in your belt. So x sine of 1 over x. So, from the question, it's continuous at 0, right? So, so continuous on R, right? Because if you think about it, the only problem is at 0 because you can't plug in 0, right? So it's certainly continuous everywhere else, and you could check it's continuous at 0. So it's continuous on all of R, but not differentiable at 0, right? And the second example was absolute value of x, right? Same thing, continuous on R, but not differentiable at 0. So you have like 2 nice examples. Okay. Any questions so far? Notice you all like typing. Okay. Let's do one more and then I'll talk about the quiz. So this one's a bit harder. So I'll do the even ones. So f of x is x squared for x rational, and f of x is 0 for, x irrational. So let me. And it's 0 for not in Q. Okay, I will let you check continuity, if that's clear. So basically, we need to check that it is discontinuous at all x not equal to 0, and a is continuous at x equals 0. So, I mean, honestly, if I were going to do this, I might as well just do C. Let's just do C. So let's prove it's differentiable at 0, and in fact, you can show it's not differentiable, right? So let me just do this. Let me just do more than what the problem asks. So let's show it's not differentiable at a not equal to 0. So in fact, you can show. So I'm gonna add not differentiable. I'll let you prove the continuity parts, by yourself. Not differentiable at a not 0. So for a not 0, we have case 1, right? When a is not in Q, right? So a is not rational. Then what do we have? Limit x goes to a, f of x minus f of a over x minus a. This thing is what? So if a is not rational, f of a is 0, right? From here, if you're not rational, my f of a is just 0. So this is just f of x over x minus a, right? And basically, what we're going to use is, okay, the idea is one of it is x. You could choose a sequence. So there exists, so this is like review, there exists sequence of irrationals going to A, and there exists sequence of rationals going to A, right? And in fact, you could choose the sequence to be, increasing or decreasing. But okay, any questions? So in the case of in this case, right? What is this limit? If I take limit, and if I take that sequence, f of xn, xn minus a. So what do I get? So this is just, oh, I need space. I'll write it here, sorry. So I'll write it up. This is just limit n goes to infinity of 0, right? Because f of xn is just 0. So this limit is 0. Because I'm on the case where, this case, my sequence of irrationals. But if I take the sequence of rationals, n goes to infinity, f of xn over in this case is xn squared, right? From here, if I'm rational, f of what xn is just xn squared. So over. So here is, the issue, right? If I'm going to A, so this thing goes to a squared, right? Goes to a squared, and I'll write quotation mark because I'm really not allowed to do that. right? It goes to like a squared over 0, right? Because xn goes to a. So I go to a squared over a minus a, right? So this thing, the point is the limit doesn't exist, right? Because remember, a is not 0. So whenever you have a number over 0, like kind of like 1 over x, right? You have 1 over 0, like this thing, does not exist, right? Because the limit from left goes to positive infinity, limit from right goes to negative infinity. But in either case, all we care about is that this thing does not exist. But really, all we care about is that these two are not the same, right? So I found two sequences that go to two different numbers, and they both go to a, right? Remember, for a limit to exist, if you remember the sequence definition, a limit exists if and only if every sequence that goes to a, goes to the same thing and exists. So here I found two things that go to like different things. So here you sort of see that when a is not 0, it's not differentiable. Okay, so when a is 0, why does the limit exist? Well, in this case, it's just in this case, this is just x on bottom, right? But also it's just f of x on top. Why? Because, yeah, f of 0 is rational, but it's 0 squared, right? 0 squared is just 0. So, okay, so now here comes the tricky part. You can't, if we want to show a limit exists, right? I can't just, basically what you want to say is take sequence of rationals. I get x squared over x, right? And I get limit x goes to 0 of x is, that's 0. And also if I take sequence of irrationals, f of x is just 0. So I get 0 either way. But the issue here is, remember, the limit definition is to show it for all sequences, right? So that's why it was sort of nice above. If we want to show a limit doesn't exist, we just need to find two sequences that don't go to the same thing. But to show a limit exists, we need to show it for all sequences, right? So that is a big of an issue. So instead, want to say this thing's 0, right? We hope so. Let's show it, right? Let's show it using instead of sequence, let's use the epsilon delta definition, right? So certainly we have that limit x goes to 0 of x squared is 0, right? So this is certainly true. So we could use this to say, so let's, let me make this star, yeah. Let epsilon be bigger than 0. So from star, we have that there exists delta such that for, I'll let you show the top part, yeah, the star. I don't think it's that hard. So such that for x minus 0 less than delta, x squared is less than epsilon, right? Technically, you don't need the 0, but just making things, this is just, right? So choose that delta. Then in either case, right, we have this. So we have limit x goes to 0, f of x over x, right? Sorry, I need to do this thing minus 0, right? For absolute value of x less than delta. We want to show this is smaller than epsilon, right? So this is f of x over x, right? And we have two cases, right? Either x is in Q and absolute value of x is less than delta, or x is not in Q. And so we need to show this is less than epsilon for any x in here, right? So you have two cases. You're either rational in there or not rational. And if you're rational, then this is just if q, then this is just x squared over x, and you know, oh, actually, oh, this is actually easier than I thought it would be. Okay, yeah, we don't even need this. Sorry about that. I wrote a mistake. So choose, basically I'm saying choose sorry. So it's actually easier. Yeah. Let epsilon be bigger than 0. Let delta be epsilon. Then for absolute value of x less than delta, which is epsilon. You get this thing's less than epsilon. So, and then here, if you know x is not in Q, then f of x is just 0, right? And 0 is certainly smaller than epsilon. Yeah, just ignore what I just wrote, like, right in the blank space. Okay. Okay, is everyone clear on this? So really everything is just use the definition of derivative, right? So obviously what I want to say is, you can clearly sort of, like 28.6, where is that? Like 28.6, right? You know, I'm using, you could do a check, right? You can use your math 2b and just check, right? So, if you just take derivative, you get sine of 1 over x, right? And then you add derivative sines cosine. You could check by hand, right? Times over x squared, and you could check, okay, is this function continuous at 0, differentiable at 0? But you could do that for every question except for the other one, right? Because the other one, because here it's true on some like interval, like not 0, but here it's too like spread out, right? Because like there are like infinitely many, given 2 rationals, there's infinitely many irrationals inside, and given 2 irrationals, there's infinitely many rationals, right? So you can't really just take derivative here, but here you sort of can, right? Because it's sort of this function outside of 0. So you can certainly just check to see if your answer agrees, right? But for most of these, you could probably do that. But really, they want you to use the definition. But to check your work, I guess you can use math 2a and see if your answer matches, right? Okay, so again, so your quiz is just one quiz this week, and it's basically on differentiation, right? So it's 3 questions. I think it's 2 true false, and it's 1 multiple answer, yeah? So 2 points each. And this is 6 points. Yeah, so multiple answer is sort of like multiple choice, but there could be more than one answer, right? So like choose the following that holds. Any questions? So it starts Wednesday at 2 p.m. Yeah. So you have a lot, right? You have like 25 minutes, I think. 25 or 30, I forgot. But the true false should take like 2 minutes. So really, you should spend your time doing the multiple answer one. Yeah. Okay. Any questions so far? Any questions at all? No. Okay. If not, I will see. Yeah, it's a Canvas quiz, just one. No, like written upload PDF. Okay.